So here's problem 42 from the review, and the question is to find the instantaneous rate of change when f of x is equal to x squared minus 2 over x plus 4 when x is equal to negative 1. Where is it? No, that's not the way I read that. That's the way I read that.
Because they would use parentheses.
They would use parentheses if they intended that to be the entire denominator. So you double check that with the solution manual. What I'm going to do is I'm going to bowl ahead on this. I'm going to say that f prime of x is equal to 2x. Now, I've done this 1 over x problem so often that I know that it's, so there's my constant multiplier, and I believe it's negative 1 over x squared is the derivative there. And of course the derivative of 4 is 0 because it's a constant. So let me clean that up again a little bit. 2x plus 2 over x squared, which means the instantaneous rate of change, whoops, not at x, but rather at negative 1, is going to be 2 times negative 1 plus 2 over negative 1 squared, which is negative 2 plus 2, I got 0 as the instantaneous rate of change. Which would I would say that's C, and they say the correct answer is C.
That, how they put it, messed my entire...
Okay, but again, if they meant this to be the denominator, because you interpreted it as this, right?
Yeah. Yeah.
If they wanted that, they would have said paren x squared. Okay, okay, but my answer is at least consistent with what's in the answer in the odd numbers. They declare it's in my book. They say the answer is C, and I got C. So, by the way, it also says here you may use a graphing calculator to solve the following problems. How could you solve this problem without doing the symbolic work? Shortcut? Can we just remind ourselves what that looks like? Here's my calculator. Did I not have my calculator running? How is that possible? Calculator. Okay, and as we wait for my calculator to start up, because it'll only take 4 or 5 minutes. Golly, it's cold in here. Oh. Well, actually, I'm waiting for TI to send me a code that allows me to validate my installation. All right, so if we go math and option 8 for end-deriv, we want to take the derivative with respect to x of x squared. And I got to practice moving over to the right to get out of the superscript mode. Minus 2 divided by x plus 4. And of course, we're interested in what is that value when x is negative 1. What is that number? That is 10 to the negative 6. That's a number. Let's point 0.00001. It's really close to 0. It's within the error to being close to 0. So that's essentially 0. Yeah, Aaron. Sure, want to take a look at 17? Okay, sure. Okay, first of all, you're asking for us to go into parametric mode? No? No, this is, a bullet's fired straight up. Get rid of some stuff from my earlier endeavors. Okay? Use the graph or simulation to solve the problem. So we're shooting a bullet straight up from the moon surface, and its position would be 832t, that x is going to be our t in this case, minus 2.6 x squared, which is like t squared. Okay? On the Earth, in the essence of air, on Earth, in the essence of air, it would be 832t minus 16t squared. How long will it take? How long will it take the bullet to go back down in each case? Okay, so there's our two graphs, and the question is, can we look at them graphically and see what's going on? I guess I could start with a zoom 6. And what we're seeing is it's going up very quickly. So maybe what we should do is adjust some windows here. You know what? There's a new zoom feature, by the way, that I think is worth looking at. And that is zoom alpha A is zoom quadrant 1 only. I've been finding all sorts of new things in the new version of the okay. And now we're in quadrant 1, but still can't see much of it. Why don't we adjust out our x values and y values? How about instead of from 0 to 9, how about 400?
I just did zoom fit before.
Yeah, zoom fit would probably be a better thing than what I'm doing. Zoom fit is what? 0? Right. And what zoom fit does, by the way, while we wait for it to do what it wants to do.
Oh, you have to reset it to zoom 6 and then zoom 6. So at the instead of just one block.
Actually, if I hit the on button right now, it'll stop doing all that processing. Zoom fit is what? 0. If sometimes, especially when you're doing end-deriv graphing, and you find all of a sudden, like you're doing an end-deriv to pause it. Well, I have the Earth one being bolded. Okay, but sometimes when you're doing an end-deriv graph, it takes a lot of processing, and then you find that you're a little bit off, and you don't want it to wait. You don't want it to wait to finish doing all that graphing. If you hit on, it'll stop doing the middle of the graph. Okay. I think we still need to make some adjustments here. I'm going to go to 100 for my x values. No, how about 0? And how about my y scale of about 100 instead of my max 9,000? Sure. Let's try that. Sure. All right. Here's the moonshot.
Does it make your x max?
I made my X max 100. Well, certainly if we're going to do the moon stuff, the moon stuff didn't come back down. So we're going to go 500. Things in my way again. How about we go 500 and let's go step at 100. And then for the moon stuff still went too high. So where do you want to go? 15,000? Okay, well at least the moon stuff came down. Okay, so how long does it take for it to come down? Well, at least you got it to the point where we can start looking at the tool in the graphing window to allow us to calculate this. And let's go second calc. And which one of these options is going to help us find? Okay, we're going to look for the zeros. In some calculators, instead of 0, it says roots, but it means the same thing. And here's the tough part. I've got to get one value for the first one, which is my y2, and I've got to get it to the left of where that root is, and I'm going to guess about 50. Is a good left bound. In my right bound, I'm going to go 100. And I don't even have to make a good guess. And they say about 52. Does that work out? Yep, that's the right answer. And now we got to do the same thing for the moon. See, 100, 200, somewhere between 300 and 400. It looks like this is where it crosses. So let me do that again. Second calc. I want a 0. I want it for the moon equation. So there's that. And as I said before, somewhere between 300 and 400. Is that what we said? You change which equation by using your up and down arrows. So there's the Earth equation. There's the moon equation. Okay, left bound, let's say 300. Right bound, let's say 400. Let's say, I don't care what my guess is. And they say at 320 is when it falls back to the moon when you shoot the bullet up.
It says in the absence of air.
I don't know how the gunpowder gets ignited in the absence of air. Because isn't oxygen a necessary for the wait, maybe there's oxygen inside the shell already, and it's sealed. Yeah, but the impact starts a spark. It's the spark that ignites the gunpowder. You think so? What's the escape velocity for the moon?
That's Miss J. Call her up.
Okay. I do, but I don't. Yes.
How do we compensate for wind?
It would probably be a lot more complicated as far as spread. Would it involve like adding a different variable or
For what?
for where it would stop falling with wind?
Yeah. Yeah, essentially you have a vector which is pushing the bullet up. You have another vector which would be wind taking it. Yeah. All right. So I think, is that enough of 3-4?
Yes.
You know where the other ones are. Okay, great. So let's turn off this recording.